We'll add that into the challenge, the list of possible challenges to do in the future. Yash, hello. How are you doing today? Okay, so Rust learning experiences. I think I know enough Rust for that. As a professional Swift dev, don't use Xcode for Bevy. Just download it and forget it exists and let it provide necessary binary tools. Yeah, that's sort of like how I treat Xcode is basically every time I open it, it's usually by accident. That's usually what it is. Is it's by accident. What am I building? We're going to be building Asteroids game in Rust or in Bevy. That's going to be the plan. The Asteroids game in Bevy. But we have to first learn how Bevy works before we create the Asteroids game. You wish you could treat it like that for Fire iOS and Mac apps? Yeah, that's totally understandable, right? Because like garden system or whatever, like closed garden, you don't really have a choice when you're building for the operating system that needs it. Okay, so we just create a new thing like that. So let's do. I'll keep this window here. Let's create another window over here, and I'll full screen you. And we will do a cargo. I like to do the rest up update before every project, even if I just did it yesterday. Am I a game dev? I've been studying game dev due to sudden interest in procedural games. Nice. I am not a game dev. I would not label myself as a game dev. I have let's see. In the past though, we did go through the book Game Programming Patterns on stream, and we implemented all the examples in Rust and JavaScript. And all the examples are written in C++. So that was a fun sort of like turn into JavaScript, turn into Rust. And we then did that all in what is it called? GGEZ. Sort of like implement them and then like sort of see an example in that. That was a lot of fun. That's the most like sort of game devy that I've been. So like I know something about game dev. I know enough to basically sound like I know what I'm talking about, but not enough to be able to like maybe talk to an actual game dev and convince them that I know what I'm talking about. Yeah, I believe that is on YouTube. Let me see if I can find it. I would want to say I have it on a playlist. Let's see. Would it be game? Oh yeah, yeah. Game programming patterns book. Where's the share button? Get shareable link. I know enough to be dangerous. Yeah, that's exactly how I feel about it. All right, take a look at that. That is the playlist for the game programming patterns book, which I do highly recommend. The game programming patterns book is great. I love that. The author also wrote a book on creating an operating system, I think. Or no, a compiler. Not an operating system, a compiler. I'm in a phase where I don't know 80% of the stuff and everything I write feels garbage enough to even push to GitHub. That is when we want to push more to GitHub and be even more garbage, right? I do remember there's this idea in like education, psychology, and all that stuff is that if we're feeling afraid of stuff because like we think it's like low quality or something like that, then just switch, like we can play a trick on our brain to switch to something that we know we're not good at, which then gives ourselves a excuse for like not being good at it, right? Like it's okay. I remember one thing was like, oh, I'm not very good at art. So it's like, okay, if you're right-handed, draw with your left hand. If you're left-hand, draw with your right hand. Do your art with your offhand. And in doing so, we generally feel much better about the art because, hey, we know we did it with a handicap. And then we do that enough eventually to the point where like, oh, okay, I'm feeling okay with myself not creating great things. Now I can switch back to my primary hand. So if we can figure out the same way to sort of trick ourselves into like doing good stuff in normal work, then that's great. It helps out a lot. All right. Let's see. What are we doing here? We're gonna do a cargo new. I guess we'll call this Bevy Playground. Now, okay, so they're walking us through like how Rust works here too. So we have our main entry point of the program. That's great. Cargo tomls, your project file. Yeah, that's great. Add Bevy as a dependency. Cargo add Bevy. If you're using cargo workspaces, you will also need to add the resolver to your cargo.toml file in the root directory. Interesting. I don't know what resolver does in this case. Or you can push to GitHub to trick AI. I mean, yeah. Like any tricks that we can do to help us be productive and like work past any blockers that we have is really important in my mind. Like it's one of the tricks, like one of the ways to be more productive is just to figure out how to trick ourselves to be more productive. That's really all it is. I'm not using cargo workspaces, at least for this, but that's good to know. Compile with performance optimizations. While it may not be an issue for simple projects, debug builds in Rust can be very slow, especially when you start using Bevy to make real games. It's not uncommon for debug builds using a default configuration to take multiple minutes to load large 3D models, or for the frame rate for simple scenes to drop to near unplayable levels. The frame rate to drop really sucks. Fortunately, there's a simple fix, and we don't have to give up our fast iterative compiles. Add the following to our cargo toml. Okay. So, okay, we're going to have some profile dev type stuff. So, profile.dev. Want you. Ooh, I like how I'm getting so much help here with this. I must have installed something to make this work with Helix. That's nice. Okay, so enable a small amount of optimizations in debug code. Enable high optimizations for dependencies, including Bevy, but not for our code. Okay, so basically library stuff. So profile dev package. So all packages. Opt level 3. Nowadays, Cargo always complains about the resolver version when you use workspaces, so it will tell you to set resolver equals to 2. Okay, so it's basically just whenever I use it, it will just tell me, hey, please do this to make this warning go away, which is nice. You might think to simply develop in release mode instead, but we recommend against this. Yeah, we don't want to worsen the development experience. Enable fast compiles, optional. Bevy can be built just fine using default configurations. Okay, so fast compiles. Enable Bevy's dynamic linking feature. This is the most impactful compilation time decrease. If Bevy is a dependency, you can compile the binary with the dynamic linking feature flag. Enables dynamic linking. Yeah. We're not in Windows, so I don't need to worry about enable performance optimizations. Okay, so we want to add in the features Bevy dynamic linking when we run. If you don't want to add the features Bevy dynamic linking to each run, this flag can permanently be set via cargo.toml. Oh, nice. Okay, so we can just, we just add it with the features. So, hold on. Wasn't the Rust team supposed to come out with a new linker like a year ago? I don't really remember. I haven't really been paying attention. So let's see. Let's just add it as the feature, right? And 42 deactivated features. They don't let me see them all because there's too many. Is it dash capital F? There. So that should add the feature they want. Dynamic. Yeah, there it goes. Dynamic linking is added. Remember to revert this before releasing your game. Otherwise, you will need to include. Oh, okay. Never mind. I don't want to add that as a feature. Because if you all want to play this, this won't work then. Never mind. Okay, so we'll just do the other method. So to get this going in my terminal so I don't forget it. Where do I want to put this? I can put you up here. Do I want that one or do I want maybe you over here? Okay, other things we can do. LLD linker. The Rust compiler spends a lot of time in the link step. LLD is much faster at linking than the default Rust linker. To install LLD, find your OS below. Okay, so we can use... yeah, I'm not going to go through all these things. I don't... Like, it'd be nice to, like, make it super fast, but we're not going to make a huge game anyways. So it's probably not going to be that bad. And before, like, 5-minute compiles, right? All right, so this will take a while. Bevy programs are referred to as apps. The simplest Bevy app looks like this. Use Bevy Prelude, app new run. Okay, yeah. I mean, that's probably just going to bring up a window, right? So if I come over to main and we just say, oh, it's busy compiling, and so Rust Analyzer is not going to be allowed to run, is it? Because I remember that, like, Rust Analyzer has to wait until the compilation ends before it can do its thing. So we're not going to get any help whatsoever. Oh, that's fun. Is this the same building from like 2 minutes ago? I believe so, yeah. But theoretically, the incremental builds should be much, much faster. But this reminds me of the good old compilation times we got a few years ago with Rust. That was not great. Okay, so you're good now. So now we should be now Rust Analyzer should be able to load and give us some help. So I want app. Oh, is Rust Analyzer going to take forever to load because it has to do the same compilation step? Because it uses the same compilers behind the scenes, right? Okay, you're done. So if I do app, okay, use Bevy app, new, run. Okay, so if we just have this, we'll move over to the right and we'll do I'm gonna do the same cargo run with that features. Yeah, significantly faster, but obviously, well, I was kind of expecting a window to show up at the very least, like a blank window, sort of like what you get with GGEZ. I'm also kind of surprised they don't suggest cargo run with the feature that they recommended that you use earlier. Yeah, nothing happens. This is because we haven't told our app to do anything yet. Apps are just empty shells capable of running our application logic. If you'd like to learn more, then continue reading. Otherwise, okay, so what makes an app? So, what sort of data does our app really store? Looking at our docs link, we find three fields: world, schedule, and runner. Right, because they use an ECS. So we're going to use ECS terms in here too. So the world is going to be the ECS stuff. That's where all of our entities live that are going to be in the world. Schedule, my guess, is going to be for we're going to be able to like nothing runs exactly when we tell it to run. We can say like, hey, run it right now, but it's really just scheduled to run immediately. Sort of like a cube, my guess is. I've never really used, I think I mentioned before, I've never really used Unity or Godot or anything like that. So I'm not familiar with like how those systems work. My guess is that they have a similar sort of idea. The world field stores all of our game's data. The schedule holds the systems that operate on this data. Okay, so the schedule is the systems. So back to the ECS stuff again. We have our systems. And that mutates or does stuff to the things in the world. And the runner interprets the schedule to control the broad execution strategy. You can read more about these by exploring the reference documentation linked just above. Okay. Generally, you'll be operating at a more granular level than these basic primitives, controlling data in terms of specific resources or components, and adding systems to an existing schedule. To do so, customize your own app by chaining its methods with the builder pattern. The most basic tools are initializing resources in the world to store globally available data. that we only need a single copy of, adding systems to our schedule, which can read and modify resources in our entities components according to our game logic, importing other blocks of app, modifying code using plugins. Okay. We'll cover these a bit more in the next pages. Speaking of which, let's finally add some logic to our game using Bevy ECS. All app logic in Bevy uses the entity component system paradigm, which is often shortened to ECS. ECS is a software pattern that involves breaking your program up into entities, components, and systems. Entities are unique things that are assigned groups of components, which are then processed using systems. For example, one entity might have a position and velocity component, whereas another entity might have a position and UI component. Systems are logic that runs on a specific set of component types. You might have a movement system that runs on all entities with a position and velocity component. The ECS pattern encourages clean, decoupled designs by forcing you to break up your app data and logic into its core components. It also helps you make your code faster by optimizing memory access patterns and making parallelism easier. We have our the ECS system that we created ourselves, which is based upon Specs, which was the original one that Bevy used before they switched to making their own. So my guess is that they're sort of like based a little bit on Specs. Custard Beard, hello. How are you doing today? ECS is the answer to object-oriented programming and gaming. It does feel like everyone just sort of like ECS is the thing to do. Bevy ECS is Bevy's implementation of the ECS pattern. Unlike other Rust ECS implementations, which often require complex lifetimes, traits, builder patterns, or macros, Bevy ECS uses normal Rust data types for all of these concepts. Components, Rust structures that implement the component trait. Yeah, so we just derive component from that, which that does remind me of Specs a bit. Systems, normal Rust functions, which is nice. The query is always the fun part. Oh, but that is a nice query. That is better than Specs. Entities, a simple type containing a unique integer. Now let's see how this works in practice. Your first system. Paste the following function into our main.rs file. Okay, so we're going to have a hello world. I guess this is a system. It just prints this. So function hello world. This will be our first system. The only remaining step is to add it to our app. Okay, so on this new, we're going to add in an add systems. And interesting. So we have update. The schedule that contains app logic, ideally containing anything that must run once per render frame. Okay. And then hello world. Note that we're not using the parentheses here, which means we're passing the function in directly as opposed to running the function and passing the result into add systems. So my guess is that on every frame, it runs hello world. That's my guess. The add systems function adds the system to your app's update schedule, but we'll cover that more later. Now run your app again using cargo run. You should see, oh, it's only going to print once. Interesting. I was sort of expecting that to print many times. Object-oriented just has bad issues in gaming, so ECS lets you group logic, but without the OO overhead. Yeah, I totally get that. There's who was it? I watched a conference talk from a game creator. It was like what game was it? Was it like I remember the name anymore. It was like a space Terraria or something like that type game. And she had used object-oriented programming mostly because that's what she was familiar with, and she wasn't like big into game design beforehand. She really didn't know about ECS, and like by the time she learned about it, it was too late. Like they already had like the game released or scheduled, and they couldn't like rebuild it at that time. It was an interesting talk about like, oh, this is, you know, it is absolutely possible to use object oriented in like, you know, bigger games, but here are the limitations to that. Your first components. Greeting the whole world is great, but what if we want to greet specific people? In ECS, you would generally model people as entities with a set of components that define them. Let's start simple with a person component. Okay, yeah, so now we're going to create components, and an entity is made up of multiple components. So we'll have the struct person. Okay, ad break is starting in 1 minute. I'll probably take a break during this one too. All right, so we derive component for this. But what if we want our people to have a name? In a more traditional design, we might just tack on a name string to field to person, but other entities might have names too. For example, dogs should probably also have a name. It often makes sense to break data types up into small pieces to encourage code reuse. So let's make a name its own component. Yeah, and I think the other thing is that what if a person doesn't have a name? Like it is possible that like when you're dead, you remove the name or something like that. There's a lot of things that we could do about that. So we're going to drive component, struct name, throw the string in there. We can then add people to our world using a startup system. Startup systems are just like normal systems, but they run exactly once before all the other systems right when our app starts. Let's use commands to spawn some entities into our world. Should be more like named rather than person, as a person would be a combination of components. Yeah, I know, like person doesn't feel like, just feels weird as like a component, right? Like wouldn't a person be just a collection of components like name and something else? Like a person would be not be, I feel that should be an entity. All right. Ad just started. I'm going to take a quick break, so I will be right back. All right, I'm back. I tried to convince Zilby to come down, but he wasn't interested. If you break down your game into systems such as player input, AI controlled, physics, collision, movement, then you would combine all those components to form a player, and combining just physics collisions for things like rock and AI controlled for a bee swarm. Yeah, that does make sense. Yeah, that's sort of like my understanding too, is you want to think of like the entities that you have as opposed to the components, and then when you're thinking of the entities, you think of the components then, right? So like you wouldn't think of a person as a component, but you think of all the things that make up a person as the component. That would be hilarious to have AI control on a rock though. All right, so we did person, we did this name thing. We can then add people to our world using a startup system. Startup systems are just like normal systems, but we already read through that. So add people. So now we have another system, and already our organization here is bad, but this is our playground. So that's the reason. We're fine. I'm not sure I'm happy about the name of this too, because like I'm thinking that this should be like an initialization function, like init or something. Okay, so we're gonna have commands, and this takes in commands. Interesting. Just that. We don't return anything. Ah, so we're gonna do commands.spawn. It's gonna take in a tuple. Okay, so it's gonna be, we want component. Okay, so this is gonna be all the components. So we're gonna spawn, so create an entity, right? With the following components, and then it has to be the number of them. And then we probably have like a limited numbers, like 255 or something like that, of how many components we can have on an entity. But so we're gonna add in, so we have a person whose name is, here we'll do, you know what I don't have? That would be good to add in as like a fun software is like we have a random chooser and like random chatter for naming things. Oh, and that also would be a challenge to here using here, which be Twitch, YouTube chatters for all variable names. All variable, I guess for all names. Which would be a nightmare to work with, but that's the entire point, right? Zibby, you're gonna hang out with us? He's thinking about it. He's okay. So I moved the camera to like that new spot he wants to sit, and now he's back at his old spot again. So I don't have a camera on him. All right. So name. I'll just should I grab any of yours? Do you all mind if I use your names for this? Use. If you don't want me to, let me know and I'll remove it. Just going in order of most recent that I've seen here. Well, to own that instead of to string it, that's fine. Let's see. Then we have stacking and epic. You're not happy. The trait bound person name bundle is not satisfied. Interesting. What did I do wrong here? So I'm adding that as the name. Okay, so spawn tuple person name, and then closing. It is commands, which is based upon commands. They're both components. Oh. Semicolon. That was a really, really bad error message for just missing a semicolon at the end of the struct. Now register the startup systems like this. Okay, function main. Okay, yeah, so we have our app new. We have our adder systems. So that's okay. So before, so add systems update hello world, which runs once, and then we're going to have another add systems on startup. We're going to add people. Now nothing's going to change because like this adds these three entities into the world, but it's not going to really do anything with them. But we're probably going to, yeah, right here, our first query. We're going to query for these people. Your first query, we could run this now and the add people system would run first, followed by hello world. But our new people don't have anything to do yet. Let's make a system that properly greets the new citizens of our world. Okay, so instead of our hello world, I'm kind of surprised we're not changing hello world. We're creating a new one. So function greet people. Oh, there it goes. Zilby's now moved over. Okay, so we're going to have a query. Now this uses a query struct. We want, okay, so we want to get the name and we put in the structs that we want out of it, right? So name with person. That's interesting. That's super easy. And I wonder if I wanted multiple, do I hand a, it's just multiple here? Could I just like continue to add in? I wonder. Okay, so for now for okay, so they're doing for name inquiry, but I kind of feel like this would be for person inquiry, right? Because like these are all the people. So for name inquiry, we're gonna print line hello name. That. Oh, but I Sylvie, don't do that. Sorry, those are only hung up on drywall hooks, and I'm a little bit concerned that he's going to pull it down onto himself. I need to probably find a new place either for that to hang or for his tree to go. So he's not like encouraged to use it as his scratching board. But he will pull that down. Cats are surprisingly strong. Right, so I have to get the first one out. Now, for name and query, right. Get the name that has the person also attached to it. Because there is that, can I, oh, I guess, okay, let's start this. Let's not do anything crazy. We're just going to do this. Now, if we run the app, we're going to get all the hellos. Wait, we don't? Oh, greet people. We have to add the system's greet people. So in update, we do hello world and we do greet. There we go. So we have hello custard beard, hello stacking, hello epic blarg, and then obviously hello world again runs once. What I'm wondering though is, because I only care about this one name right now, I should be able to grab the first things around it like that, right? Like I want to... Oh, it won't let me do that. I was seeing if I could destructure. Oh, put name before. Oh, you're right. Yeah, for name. Destructure it like this. That gives me the name, and then yeah, there we go. That's how to do it. So now when we run this, we get exactly the same thing, but I've grabbed this out. Now this only works because we only have one thing that we care about in here, which is, well, the name component on the people. Quick note, Hello World might show up in a different order than it does below. This is because systems run in parallel by default whenever possible, which is nice. Your first mutable query. If you want to change the names of some people, perhaps they got married. Yeah, that's gonna get awkward here with my name choices. For example, we can do this using a mutable query. How about instead we give everybody an exclamation point. How about that? Okay, so we have our update people. So we're going to have a mute query, which is the same query. We get a mutable reference to a name as long as the name is with the person component. Chat got married. Yeah, that's exactly it. Okay, so for mute name in mutable reference to query, because I don't want to take ownership of it. So this is basically not changing any other name. It's just changing that one, which seems a little bit weird. Like usually systems you want to do something to everything, but I understand how that is. Maybe how about this custard beard? I put an underscore in yours. What if I replace the underscore? So if name.0 contains an underscore, we're going to do name.0. Okay, so we can just reassign it here. Is, can I do a replace? Replace creates a new string. Okay, so name.0 equals name.0 replace and then 2 space. And then we're going to break. We're done. Oh, but underscore is your middle name? Okay. Here, well, I can fix that. How about that? It's now we're making it more of a proper middle name now. We need to make query mutable and use a mutable reference to the components we want to change. Don't forget to add the system to the update schedule. Right. So on update, now, interesting. So they're chaining those together with greet people. So we have update people. What? How did you? Okay, hold on. Update people, greet people, and then we chain this. And then runs that. Okay, so this is going to, okay, so it's going to make sure that the update people runs before greet people runs. So that way it changes. Will the name keep growing per frame? Yes, it will. That will absolutely keep growing per frame, won't it? It's perfect. Okay, so we see that. Now we only have one frame, so it's fine. It's fine. Nothing possible bad can come from this. We need to make query mutable and use a mutable reference to the components we want to change. Don't forget to add the system to the update schedule. Okay. Redo that. Note that we have used .chain on the two systems. This is because we want both of them to run in exactly the order they're listed in the code, with update people occurring before greet people. If they weren't, the name might change after we greet the people. But we don't add the hello world system to the chain because it doesn't matter when it runs. This way Bevy can run hello world in parallel while the other systems are running, which makes sense. Plugins. One of Bevy's core principles is modularity. All Bevy engine features are implemented as plugins, collections of code that modify apps. This includes internal features like the renderer, but games themselves are also implemented as plugins. This empowers developers to pick and choose which features they want. Don't need a UI? Don't register the UI plugin. Want it to build a headless server? Don't register the render plugin. This also means you are free to replace any components you don't like. If you feel the need, you are welcome to build your own UI plugin, but consider contributing it back to Bevy if you think it would be useful. Those not contributed back into Bevy and instead released separately are third-party plugins. These are useful and easy to use additions created by fellow developers that can help you avoid reinventing the wheel. To use them, all you have to do is find a third-party Bevy plugin, add it to your cargo toggle as a crate, import the code definitions, add the plugin to your app with like add plugins. Okay. However, most developers don't need a custom experience and just want the full engine experience with no hassle. For this, Bevy provides a set of default plugins, which is nice. Oh, and Zilby, I chased Zilby off, so he's no longer here. Let's make our app more interesting by adding Bevy's default plugins, which are a plugin group containing core engine features. For those needing minimal features, minimal plugins exist. Add plugins, default plugins adds the features most people expect from an engine, such as a 2D, 3D renderer, asset loading, a UI system, windows, and input. And not surprisingly, it comes in first, right? So we add the plugins, default plugins up here. So That can't find that. Why can't you find that? Huh, no code actions available. So far, it's been able to find anything just fine. Is it in Prelude? It is in a Prelude here. Is there like a plugins? Oh, default plugins just straight up there. Okay. Except, no? Expected semicolon right here? Why? I have a semicolon here. I don't have a semicolon there. That seems wrong. Okay. So you're fine. Add plugins. Okay, I don't know what I did. I apparently had a character or something in there that was bad, but deleting it and recreating it works just fine. Okay, so now when we run this, we should right, it's hello Custer, your name is now growing infinitely. I have that debugged. Now we can see your name growing forever. Which I like the way that it looks is just that it's shooting off the beard part of your name. But okay. You should hopefully notice two things. A window should pop up. This is because we now have window plugin, which defines the window interface but doesn't actually know how to make windows. And WinInit plugin, which uses the WinInit library to create a window using your OS's native window API. Your console is now full of hello messages. This is because default plugins adds an event loop to our application. Our app's ECS schedule now runs in a loop once per frame. We resolve the console spam in a moment. All right. Creating your first plugin. For better organization, let's move all of our hello logic to a plugin. To create a plugin, we just need to implement the plugin interface and add the following code to your main.rs file. Okay, so it's going to be a struct. And apparently ads can start in about a minute again. I'll work through this one. So we'll have a struct hello plugin. Okay, so we import plugin. Oh, it can't find that. For hello plugin. There it goes. Now you can find it. Okay, so we're going to have function build. Add the things to your app here. Then register the plugin in your app like this. Okay. So add plugins, and there's going to be a tuple. Note add plugins can add any number of plugins or plugin groups like default plugins by passing in a tuple of them. Now all that's left is to move our systems into hello plugin, which is just a matter of cut and paste. The app variable in our plugins build function is the same builder type we used in our main function, right? So we can just do add app.add systems in there. So basically take this one. Oh, here, let's just go. We'll do it ourselves. So we'll do app add systems. Now, why would we want to add people here? Wouldn't I only want to add the systems for Hello World? I mean, I'll do it. It just doesn't feel right. And then my guess is next we're going to delete those two systems from up here. Otherwise, we're going to have two of them running. Try running the app again. It should do exactly what it did before. Yeah, so here we go, and it does exactly what it did before. Perfect. Resources. Entities and components are great for representing complex, queryable groups of data, but most apps will also require globally unique data of some kind. In Bevy ECS, we represent globally unique data using resources. Here are some examples of data that could be encoded as resources. Elapsed time, asset collections, renders. Tracking time with resources. Let's solve our app's hello spam problem by only printing hello once every 2 seconds. We'll do this by using the time resource, which is automatically added to our app via add plugins, default plugins. Okay, so we already have that. For simplicity, remove the hello world system from your app. This way we only need to adapt the greet people system. Okay, so we're going to remove the hello world system. Now, if we remove the hello world system, we don't need this tuple anymore. So it could just be update. Oh, we do need to update people like that, don't we? Resources are accessed in much the same way that we access components. You can access the time resource in your system like this. Okay, so in a greet people, okay, so now what's interesting to me is that they have query come first. And I'm wondering if the order matters here or if it's going to be something like Axum where these are all, it doesn't matter. As long as it like impulls the right thing, it'll work. Okay, res, pull that in. Time, pull that in. Res and res mute pointers provide read and write access respectively to resources. The delta field on time gives us the time that has passed since the last update. But in order to run our systems once every 2 seconds, we must track the amount of time that has passed over a series of updates. To make this easier, Bevy provides the timer type. Let's create a new resource for our system to track elapsed time with a timer.